Well, we're going to go over the second paper, the calculator paper for the 2023 Nat 5 Apps exam. So question 1 were 4 marks. A lake had a volume of 14,730,000 litres. Due to decreasing rainfall, the volume of the lake is expected to decrease by 2.8% annually. Calculate the expected volume of the lake after 3 years. Give your answer to 3 significant figures. So if something is decreasing by 2.8%, in this case the 14,730,000 litres, and if it's decreasing by 2.8% annually, that means it is then falling to 97.2%. So I've just taken 2.8% away from 100. So if something is decreasing by a percentage, then that's what it's losing, right? So if it starts out at 100% of its original volume, then if it's losing 2.8%, then it's going to have 97.2% left. And so this is happening each year. So that's annually. So I'm going to convert the 97.2% into a decimal. So this is the multiplier. So this is 0.972. And because it's 3 years, so 3 years, I'm going to multiply the original volume by this number raised to the power of 3. So the calculation I'm doing is 14,730,000 times 0.972 to the power of 3. And when you put this in your calculator, it's going to be 13,527,001.6. And we're wanting to round this to 3 sig figs. So I'm going to draw a line after my 3 significant figures. And I can see that the 4th significant figure, the 2, is lower than 5. So this is going to be 1, 3, 5, and all of the others go to 0. And we don't need the decimal place. So this is 13,500,000 litres to 3 significant figures. Okay, so question 2. A glazer is edging the perimeter of a window. The window is in the shape of 2 rectangles and 2 identical quarter circles. So here we've got a rectangular section, we've got quarter circles, and we've also got this sort of rectangular section at the top as well. So calculate the length of edging required for the perimeter. So we need to do the whole way around here. So let's calculate the circular parts first. So the circular circumference. So you notice we've got 2 quarter circles. And the circumference, so if I just remind you, the circumference of a circle is pi times the diameter. And the diameter is 2 times the radius. And we've got a radius here of 700 millimeters. And so the diameter, is going to be 2 times 700, which is 1,400 millimeters. Now that's for a full circle. We've got 2 quarter circles. So we've got 2 times a quarter of that. And 2 times a quarter is a half. 2 quarters is a half. So what we're doing is finding effectively a semicircle. So it's a half pi times the diameter, or pi times the diameter divided by 2. So this is going to be a half of pi. You can use 3.14, but I'll use pi, times the diameter, which is 1,400 millimeters. And that there comes to 2,199 millimeters. So now we want to do the rectangular section. So the rectangular section. So let's see what we've got. We've got 1000 mil, 2300 mil, and then we've got another 1000 mil. So it's not given to you, but it's just the same as the opposite side because it's rectangles. We've also got this bit at the top here, which we're going to have to figure out. So what would this be? Well, if we know that from here to here is 700, and from here to here is also 700, then the difference here will be this 2300 minus 700 minus 700, or 2300 minus this 1400. So the rectangular section is going to be the 1000 plus the 2300 plus the 1000. And what we're going to do is we're going to add the 2300, but then we're going to subtract the 1400. And that there is this missing side. So that bit there is this calculation here. So in the calculator, we get 5,200 millimeters. And so now the total, the perimeter, so the edging, it's just going to be the 2,199 plus the 5,200. And that comes to 7,399 millimeters. So question 3. Fiona is having her back garden redesigned. A new fence is to be put from A to B and then from B to C. So before we move on with that question, let's just get ourselves familiar with the diagram here. So we've got a patio, a triangular section, that's a right angle triangle, it's a patio. And then we've got the fence which surrounds the lawn. And you'll notice that this is also a triangle, that's a right angle triangle. So we've got a fence that's to be put from A to B. So the fence has to go along this section here. And then from B to C. So from this part here. We're already given the length of A to B, but we don't have the length from B to C. That's what we have to find out first. We're given some dimensions of the patio. So it's a right angle triangle with a height of 5 and a base of 7. So if we work backwards, if we want to find the length B to C, we can find the length of a right angle triangle if we've got the other two lengths. So we've got the hypotenuse, but if we had this here, we could use Pythagoras' theorem to calculate this BC length here. So how do we then, first of all, calculate this one from A to C? Well, we can use Pythagoras' theorem for that. So we can find that by using Pythagoras' theorem on the other two sides. And once we've got that, we use Pythagoras' theorem again to find that length. So we're using Pythagoras' theorem twice. So let's go ahead and calculate AC. So the length AC, that is equal to the square root of the sum of the squares. Because we're looking for the long edge, we're looking for the hypotenuse, it's just the other two squares added together. So 5 squared plus 7 squared, the square root of that comes to 8.60 meters. So I can put that in, that's 8.60 meters. So now we've got the two sides of this right angle triangle. So now we can use Pythagoras' theorem again to calculate the BC section. So BC equals, so I'm going to use Pythagoras' theorem. Now this time, well, we've got the hypotenuse, that's AC, so that's this 21 metres. And we've got the other shorter side, so we are looking for one of the shorter sides. And by that I mean it's shorter than the hypotenuse, because the hypotenuse is always the longest side. So because we've got the longer side, we're going to use this form of Pythagoras' theorem where we're going to subtract. So we're going to do the 21 squared, so it's always the hypotenuse, the longer side first, minus the other side, which is this 8.6 squared. So you put that into your calculator, and we're going to get 19.16 metres. So now we've got the size that we need. So the lengths, so the new fences to be put from A to B and B to C. So the next section is the rolls of fencing are 3 metres long and £22 per roll. Calculate the total cost of the fencing. So the length of the fencing is going to be the AB plus the BC. So it's going to be this 21 plus this 19.16. And that is 40.16 metres. So we need 40.16 metres of fencing, but the roll's coming 3 metre lengths. So how many lengths do we need? Well, we're going to do, so rolls needed. That's going to be this 40.16 divided by 3. And that comes to 13.38. We can't get 0.38 of a roll, so we have to round up to 14. And the last section, so we need 14 rolls, and each roll costs £22. So we're going to take this, so the cost is going to be £22 times the 14, and that comes to £308 for the total cost. Question 4. The reception area in a hotel features a large mirror. The mirror is in the shape of a square and it's got identical semicircles on each side. The square has sides of length 1.2 metres, the semicircles have a diameter of 0.7 metres. Part A is calculate the area of the mirror. So we've got a square and we've got 4 semicircles. So to calculate the area, well, you need to know the area of a circle first of all, which is pi r squared. We've got four semicircles, which really that's 2 circles, 2 full circles, right? So we've got a circle here and a circle there. So 2 semicircles make a full circle, and we've also got 2 semicircles here. So we've actually got 2 circles, 2 full circles. So the area is going to be 2 circles, so 2 times pi r squared. And then we're going to add that with the area of the square. And the area of the square is just the length squared, which is length times breadth, but the length and the breadth are the same, so just length squared. So let's see if we've got everything. So let's go back up to the data. It says the square has a size of length 1.2 metres, so that's what that is. So that's going to be plus 1.2 squared. And then it says the semicircles have a diameter of 0.7 metres, but the equation requires us to have the radius. So the diameter is 0.7 metres, so the radius is half of that. So you have to divide that by 2 to get 0.35 metres. So this is going to be 2 times pi times 0.35 squared plus just let me move that down, plus this 1.2 squared. So you put that into your calculator, and we get 2.21 meters squared. So part B here, so we've got the continuation of this. The hotel bought a different mirror for the ballroom. The options for mirrors are shown in the table. So we got various sort of furnishings. We got glass coatings. So we've got standard glass coating and then the anti-glare. Notice these are in per meter squared here. We've got fixings. So we've got basic, standard, premium, and these are just per mirror. We got the backing. So no backing, and then foil backing, and that's per mirror. Then we got the glass colour and thickness. We got bronze, silver, gold, and these are all per metre squared. So we got 4mm and 6mm under each of these colours. So the first thing is it tells us that the hotel bought a mirror with an area of 3 metres squared. So let's do this step by step. So the hotel chose the following options for the mirror. The first thing is 4mm thick silver glass. So 4mm thick silver glass. So we've got the silver here, and it's the 4mm. So that's £38 per square metre. So this is going to be £38 per square metre. How many square metres is it? 3 square metres. So per square metre, we've got 3 of them. We're going to have to times that by 3. The next part is the anti-glare coating. So we're going to add that with the anti-glare coating. So let's see the coating. So we've got standard or anti-glare. It's £16 per metre squared. Again, we've got 3 square metres. So this is going to be 16 times 3. So that's for that one. So I'll highlight this as I'm going along so you can see where I'm getting the values from. Now we've got standard fixing. So we've got standard fixings. So here we've got our fixings and we've got our standard. So that's just £32 per mirror. So now that's just going to be plus 32. So I'm going to put plus 32 there. Remember, these are all in pounds. I'm not putting the pound sign in these yet. And the last one is foil backing. So we got backings right here, and we got foil backing, which is £20 per mirror. So we got £20 per mirror there. So plus 20. So let's calculate the total cost. So we got 38 times 3 plus 16 times 3 plus 32 plus 20, and that comes to £214. So question 5. Stuart records the chlorine levels in his hot tub. A sample of the levels is shown below. So we got Monday through to Sunday, and we got the various chlorine levels. No units given, just numbers. So part A, for the levels, calculate the mean. The mean is just all of these values added up. So you want to do 0.8 plus 1.9 plus 1.1 plus 2.6 plus 3.1 plus 2.4 plus 2.1. So the mean, which we can have as x bar, if you add all of those up, you're going to come to 14. So add all those up to 14. And then you're going to divide that by how many there are in total. Well, there's 7 days. So you're going to divide that by 7. And so the mean is 14 divided by 7, which is 2. Part 2 is a bit more involved. We want to calculate the standard deviation. Now, there's 2 formulae for standard deviation. But the formula I'm going to use, if I'm just going to go to the front page, I'm going to go to the formula page here. So the formula I'm going to use is the first one here, this one here. If you're more comfortable using this formula, by all means use that. But this is the one I'm going to use here. I'm just going to copy a screenshot of that. And I'll go back to that. I'm just going to paste that up here so you can see the formula, which I've taken from the formula sheet. So I'm going to create a table. So we need 3 columns. So we need all the x's. All of the x's, which are these are all the x's. All of these numbers here are all the x's. We don't have to put them in order. Then we're going to have the x minus x bar part. So basically we want to do the brackets there. So we want the x minus x bar. That's just, and we'll calculate the x bar up here, which is 2. So that's just the values of the x take away the mean. And then we want to, whatever that comes to, we want to square it, so times it by itself. Then we want to do x minus x bar squared. Okay, so that'll then be the squared part there. So I'm just creating a quick table. And this takes a bit of time, so just take your time with this. I wouldn't rush this too much. Don't be too slow, but again, we wanna be accurate here. At this point, I'm going to put in all of the x values there. These are all the x values up here. So we've got 0.8. So now I'm doing 0.8 and then 1.9. I'm actually going to put all these x values in first, and I'll maybe show you why in a minute. 1.9, 1.1, 2.6, 3.1, 2.4, and then finally 2.1. I'll just make that clear, that's a 0. And I'm just put lines in for these. So I'm just doing a very basic table, really. All right, now I'm just going to get my calculator here. So I'm just going to pop my calculator on the screen, so hopefully this works okay. I think it's worth showing this, doing the demonstration. The screen's gone a bit small, but that's just so you can see my calculator. Okay, so now we're going to do the x minus x bar part. So what that means is I'm going to take all of these values and then subtract 2 from them, which is the x bar that we got from the last question. Okay, so in my calculator, I'm doing 0.8 minus 2, and I get minus 1.2. So to save myself time, instead of typing this out, so instead of doing then clear then 1.9 minus 2 like this, which is minus 0.1, I'm going to use the arrows, and I'm going to just delete that bit, and then I'm going to do 1.1 in there. So that's minus 0.9. I'm going to then delete that, and I'm going to have 2.6 minus 2, which is 0.6. So you see, I'm just trying to save myself time. So instead of typing out, minus 2 each time, I'm just typing in the first bit using my calculator just to save a bit of time here. Then I'm going to go 2.4, 0.4, and then delete, that it's 2.1 minus 2, which is 0.1. Okay, now I'll clear that, and I'm going to square all these. Now, to save myself time as well, and also just to be careful, when you've got negative numbers, if you're going to include the minus sign, make sure you've got brackets around the number. So minus 1.2 squared is 1.44. But if you did minus 1.2 squared without the brackets, you're going to get minus 1.44. That's going to affect our answer. So make sure you've got brackets around any negative numbers before you square it. Or a little naughty trick, I suppose, is just to avoid the minus sign altogether. So I'll just show you 1.2 without the minus sign. Squared is going to give you the same answer, 1.44. So when you put it in your calculator, just forget about the negative sign. Save yourself a bit of hassle. So you don't have to worry about putting the brackets in. So 0.1 squared, so minus 0.1 squared is the same as positive 0.1 squared. So that's 0.01. 0.9 squared is going to be 0.81. 0.6 squared is going to be 0.36, and so on. So I'm going to do this for all of them. 1.21, 0.4 squared be 0.16, and then 0.1 squared, we've already done that up here, 0.1 times itself, which was 0.01. So what we need to do now is find the sum of all those, because the formula, if I zoom in there, the formula is the sum of all of that, right? So what that means is I need to add all of these values up. So I'm just going to add all of those values up. So because I had this small, when I'm zoomed in, I can tell that my writing's not very good. But what I'm going to do, I'm going to find all of those. Let's try and do that a bit better. I'm just going to add all those up. So it's 1.44 plus 0.01 plus 0.81 plus 0.36 plus 1.21 plus 0.16 plus 0.01. Okay, I've gone wrong somewhere. I've made a little mistake somewhere in my calculator, maybe. I'm just going to double check. Sorry about this. So we've got 1.44 plus, I've put 0.4 there. It should be 0.1. Sorry about that. I made a mistake on my calculator there. So when I've done that, it comes to 4, exactly 4. So the sum of those is 4. Alright, now I need to just use the formula. So I've got 4 in the numerator. Let me just write this out. So S is the standard deviation. So that's going to be the square root of 4 at the top. And at the bottom, it's this n minus 1. Well, n is the number of data points we've got, which is 7. Because 7 days in a week. So n minus 1 is 6. So it's going to be 4 divided by 6. So the square root of 4 divided by 6 there. You can just use your calculator to do this. So it's going to be 4 divided by 6. And it's going to be 0.816. And that is the answer. So as you can see, it takes a bit of time to do it. But I would recommend using the table and just taking your time as you go about doing this. And be careful, like you saw with me, I accidentally, clumsy fingers, I put 0.04 instead of 0.01. So mistakes can happen in this, but as long as you get in the process, that's the main thing. Just be careful. Okay, so that's part 2, the standard deviation. Let me just make sure if I rounded that correctly. So the square root of 4 divided by 6. Yeah, okay. Just making sure I'd rounded that correctly. Okay. So question 5, part B. So his friend Colin's hot tub had a mean chlorine of 2.2 and a standard deviation of 1.4. So make 2 valid comparisons about the chlorine levels in Stuart and Colin's hot tub. So I'm just going to write this up. So first of all, Stuart, his mean was, let us remind ourselves, was it 2? Yeah, it was 2 up here. And Colin, his mean is 2.2. The standard deviation for Stuart, let's remind ourselves, is 0.816. And Colin was 1.4. So let's make 2 comments. So each comment is based on, so the first comment is going to be on the mean. And usually we start the comment on the mean, because the mean is an average. You'd go on average and then make a conclusion based on that. Well, we can see that Stuart's average is lower than Colin, or you could say Colin's average is higher than Stuart's. So it depends which direction you want to go with that, which angle you want to go at with. We could say something like, on average, Colin's chlorine levels were higher than Stuart. So that's the first comment. On average, Colin's chlorine levels were higher than Stuart's. So that's the first comment relating to the mean. Now let's do one relating to the standard deviation. So Stuart's standard deviation was 0.816, Colin's was 1.4. So Colin's standard deviation was higher, Stuart's standard deviation was lower. Again, it depends which angle you want to come at it. You could say something like Stuart's chlorine levels were more consistent throughout the week. You could say Colin's chlorine levels were more varied or more spread out. So it depends which way you want to go with it. So I'll go with the first one. So second comment, Stuart's chlorine levels were more consistent. So a smaller standard deviation means that the chlorine levels were clustered around closer to the mean. So there's the two marks there. So let's carry on with this question. Colin had a new hot tub installed in his garden. It normally takes a team of 4 workers 12 hours to complete the task. The company sent an additional worker to help complete the task. So that'll be 5 workers. All workers work at the same rate. The workers started at 8 and took a 30-minute break for lunch, determined the time they finished installing the hot tub. So this is an indirect proportion, or an inverse proportion. Think about this. If you have more workers, each working at the same rate, then you would expect the time to be, it would be quicker, right? More of you, more hands, make light work, they say. So if you've got more workers, it's going to be quicker. So this isn't a direct proportion where you increase the workers, you increase the time. That wouldn't work in this case. It's indirect proportion, which means you increase the number of workers and you decrease the time it takes. So to do this, you want to multiply the 4 and the 12 to find out. This is a measure of worker hours. So what you want to do first of all is do 4 times 12 to get the worker hours. So that'll be 48 work hours. Okay, so the question is now, if there is an additional worker, so that's 5, how long would it take? Well, if you've got 5 workers requiring 48 worker hours, you would do 48 divided by 5. And we're going to get 9.6 hours. So this is 9 hours. And how many minutes? How many minutes? Well, for the minutes, well, it's 0.6 hours. So it's 0.6 hours. So this is going to be 0.6 times 60 minutes. So this is 9 hours and 36 minutes. So 4 took 12 hours, 5 took 9 hours, 36. Let's have a look at the next part of the question. The workers started at 8 and took a 30-minute break. So let's add 30 minutes onto that. So it took these workers 10 hours and 6 minutes. So if they started at 8 o'clock in the morning, what time did they finish? Well, it's going to be 8 o'clock plus 10 hours and 6 minutes. So that's going to be 18:06 or 6:06 p.m. So question 6. Lorna is travelling around Europe. And we're given exchange rates, pounds sterling, 2 other currencies. We've got £1 for 1.15 euros and £1 to 4.94 Polish. So Lorna converted £640 into Polish. She was in Poland for 4 days. She spent 340 Polish each day she was in Poland, and she converted her remaining Polish into euros. Calculate how many euros she received. Alright, let's convert pounds into Polish. So we got £640. And we're going to times it because we got £1 sterling to 4.94 Polish. So we got 4.94. And that comes to 3161.60. So she was in Poland for 4 days and she spent 340 Polish each day she was there. So we want to find out how much she spends. So it's going to be 4 times 340. So 4 times 340 is 1,360. Now we have to find out what she has left. So we take the 3161.60, subtract 1360 from that, and we get 1801.60. So that's the Polish currency, and now we have to convert that back to pounds and then into euros, because we want the remaining Polish currency into euros. So we go through sort of 2 hoops here. We have to go back to pounds and then pounds into euros. So to go back to pounds, we have to divide, and then we have to times that by euros. So we can do this in one go. So we're going to take this 1801.60. To get it back into pounds, we have to divide by the 4.94 exchange rate. And then to get that, so that there would give you how this in pounds. And then to go from that into euro, we multiply by 1.15. So we can then times that by 1.15. And then just do this in one go in your calculator. And that is going to come to £419, euro and 40 cents. Yes, euros. So continued. Lorna visited Switzerland and decided to buy some cheese. The cost of 5 types of cheese is shown in the table. So we've got our 5 types of cheese here, and we've got the cost per 250 grams, Swiss francs. So Lorna saw 3 different deals for buying cheese. So deal A, buy all 5 for 18.50 Swiss francs. Deal B, buy all 5, get the cheapest free. And then C is buy all 5 and save 15%. So she's going to buy the 250 grams of each cheese. Let's determine the best deal for all 5. So let's do it deal by deal. So deal A first of all. All 5 for 18.50. So deal A, that comes to 18.50. Deal B. Deal B, all 5 cheapest free. So let's identify which is the cheapest first of all. So we've got 250, 750, 732. So the last one there, the mozzarella, is the cheapest. mozzarella cheapest, so we're going to add all of the others up. So 250 plus 750 plus 7 plus 3. And that will come to 20 Swiss francs. And let's do deal C now. Well, that means we have to add them all up and then subtract 15% from them. So all of them added up. Well, it's just this 20 plus the 2. So it's going to be 22 times. Now it's 15% off, save 15%. And remember, if you're saving 15%, it's just 85% of its value. So we can times that by 0.85. And that comes to 1870 Swiss francs. So clearly we can see that the 1850 is the cheapest. So we say deal A is cheapest. Okay, 6 continued. We got Lorna also purchased a paperweight as a gift. The paperweight is made in the shape of a cube with a hemisphere on top. The hemisphere is half of a sphere with a diameter of 6 centimeters. And we can see that the cube has also got a length of 6 centimeters. Cube just means that all of the sides are the same length and height. So we've got the hemisphere, which is half of a sphere, sorry. And then we've got our cube. So all of these sides are the same as the diameter of the hemisphere. So to calculate the volume, well, the volume is the volume of the sphere or hemisphere plus the volume of the cube. So I'm just going to go back to the formula list at the front. Go back to this. And we've got various volumes. So we've got a cylinder, a prism, a cone, a sphere. So this sphere is what we're looking for. And the volume of a sphere, which I'm just going to copy for you, is 4/3 pi r cubed. Let me just go back to that page. Oh, there we go. I'll just post that there. So the volume of, that's for a full sphere. So a hemisphere is going to be divided by 2. So let's calculate the volume of the hemisphere first of all. So it's going to be 4/3 times pi times radius cubed, which is, and then it's going to be divided by 2, right? So then we have to divide all of that by 2, because it's half of that. So it's going to be 4/3 times pi times the radius cubed. What's the radius? Well, we're told the diameter. Is 6. So we've got the radius must be half of that, which is 3. So it's 3 cubed, and then we're going to divide that by 2, like this. I'll get my calculator just in case you're unsure how to put this into your calculator. Now your calculator, I'm using an app on my iPad. Your calculator will hopefully look similar to this, but what you want to do is find your fraction button. So you want to get 2 boxes like this. In the top, you're going to put 4, arrow down, press 3. That's your 4/3. As a decimal, it's 1.3 recurring. Press your right arrow, and then we're going to times that by pi, and we're going to times that by the radius cubed. We don't want square, we want cubed like this. And then we're going to divide that answer by 2. So we're going to get 56.548, 56.55. Cubic centimeters. And then the volume of the cube, I'll just take that away. So the volume of the cube, that's, well, its length, breadth, height, and they're all 6. So it's 6 times 6 times 6, or 6 cubed. So it's 6 times 6, 36, times 6, 216. So the volume, total volume, is going to be this 56.55 plus the 216, and we get 272.55 centimeters cubed. Okay, question 7. So Dave has a job in an office typing documents. He is contracted to work 35 hours per week. He earns £11.20 an hour. He is paid time and a half for any overtime he works. Last week Dave worked 37.5 hours. Calculate his gross wage. Gross wage means income before any deductions. Because he gets paid time and a half for any overtime, and he works 37.5 hours in total, but he's contracted for 35 hours, how much overtime does he do? So the overtime, first of all, is 37.5 minus 35, which is 2.5 hours. I will one day learn how to do a 5 properly. There we go. Alright, so it's time and a half for 2.5 hours. So time and a half. Time and a half means 1.5 times, so 1.5. So we're going to take this 2.5 hours and we're going to times that by 1.5. And that'll tell you, and then times by the wage, sorry. So it's 1.5 times this £11.20 per hour. So 1.5 times is standard salary. So 2.5 times 1.5 times 11.20. That'll give you time and a half for 2.5 hours. That comes to £42. But then we've got to add on the rest of the hours, the 35 hours. So the 35 hours at £11.20. So now we're going to do 35 times £11.20, which equals 392. So the gross weekly that he got for last week is equal to 42 plus 392, which is £434. That's his gross wage. Alright, so Dave records the number of words per minute that he typed during a 14-minute period. And we've got 14 data points there, each words per minute. For the data, calculate the median, the lower quartile and the upper quartile. So to do this, we need to order the numbers. So you need to go through all the numbers here and put them in order. So this takes a bit of time because there's 14 numbers to order. So just take your time with this. So let's go through. What is the lowest number on here? What is the lowest data point? Well, it looks like it's 37 to me. So what I'm going to do is I'm going to cross these out as I go along. So I've got 37. Because I've got 14 of them, I'm going to write these small. So I've got 37. I have another 37 there. So I'm going to write 37 here as well. Then I've got 39. Then I've got 41. I'm looking, have I got any other 41s? No, but I've got 42 there. Then I've got 44. I've got two 44s. I've got one there, and I've got one there. Okay, now I'm looking, no 45. We've got 46 right there. And then we've got 47. We got another 47 right at the beginning. We got 48, so 48. Any 49s? Got 49. Nearly there. We got 51, then 54. So 51, and then 54. So just take your time when you do that, making sure you don't miss any out. If you do miss any out, just start again. So let us then figure out the median. So the median, what we've got, is we want to split this data into two groupings, a lower and an upper grouping, or a lower half and an upper half. Because we got 14 data points, we're going to have two groups of 7. We're going to have two groups of 7 like that. And the middle number, well, we're not going to have a middle number. We're going to have to find the average of the two middle numbers. So I've got a grouping of 7. I'm just going to count this. 1, 2, 3, 4, 5, 6, 7. So it's going to be between these two. So let me just do my groupings. So that's my first 7, and that's my last 7. So the median is going to be exactly between 44 and 46. So it's going to be 45. So you do 44 plus 46 divided by 2. Here it's easy because it's just the number in the middle of 44 and 46. So it's going to be 45. Now we're going to do the lower quartile, which we call Q1. And it's basically the median of the first half. Now we got a grouping of 7, so that's two groupings of 3. So two groupings of 3 with Q1 in the middle. So it's actually the fourth number. So we've got 1, 2, 3, and it's going to be this number here. So this here is Q1. So that's 41. And Q2, it's the same, but for the second grouping. We're basically splitting the second half of the data into 2. So two groups of 3, and it's the middle number, which is 48. So that's the median, the lower and the upper quartile. Actually, sorry, I've put Q2. Q2 is actually the median. I meant to put Q3. So the median is what Q2 is. I made a little mistake there. My apologies. So the lower is Q1, the upper is Q3. So 7C, we are going to create a box plot. So what's our lowest value on here? So we need our lowest value, which was 37. So let's just have a look at this. So it looks like they've already done the scale for us. It's 1, 2, 3, 4, 5. So let's have a look at 37. 37 is going to be here. So I'm just going to mark these. That's where our lowest data point is. Our upper data point is 54. So I'm going to take the upper data point, 54, and I'm going to put that on here. So 54. So we got 50, 51, 52, 53, 54. So it's going to be here. That's where 54 is. So I'm just going to draw a line there. So let's look where our Q1 is going to be. So Q1 we calculate as 41 up here. So 41 is going to be here. So 41 is there. So I'm going to draw this line here. Our median, so Q2, is 45. So I'm going to draw a line at 45. Our Q3, so our upper quartile, is 48. So 48 is here. And I'm going to draw a box around the quartiles. So I'm going to connect these like this. Try and use your ruler to get it as neat as possible. That's my box. And the whiskers of that are just going to extend from the middle of the box out to the lower and upper values. And that there is our box plot. So calculate the interquartile range, the IQR, for the number of words Dave can type per minute. So the IQR is the upper quartile minus the lower quartile. Q3 is 48. Q1 was 41. So the IQR is 7 words per minute. Lynn works in the same office as Dave. Lynn also records the number of words per minute that she can type. The interquartile range, the IQR, for the number of words that Lynn can type per minute is 5. Make one valid comment comparing the number of words Dave and Lynn can type per minute. So Dave, IQR is 7. Lynn, IQR is 5. It's not enough to say that Dave has a high IQR or Lynn has a lower IQR. The IQR is similar to standard deviation. It's a measure of effectively consistency or spread. So what you could say is, like standard deviation, the lower the IQR, the more consistent or the less spread out the data points are, or the greater the IQR, the less consistent. So you could say that Dave is less consistent than Lynn. Or Lynn is more consistent than Dave. So 7 continued, so part E. Lynn earns £1,052 a week. National insurance is calculated on a person's wage before deductions, such as pension contributions. So we've got the rates for national insurance. Calculate Lynn's weekly national insurance payments. Okay, so we've got Lynn's weekly wage, and we can see that it's over the higher amount there, and that is at 3.25%. And then we've got everything between 242 to 967 is at 13.25%. So we've got 2 sort of stages to do here. So let's calculate Lynn's national insurance. First of all, let's calculate the 3.25%. So you want to do 1052 minus the 967. So that's anything over 967. So that comes to 85. Then you're multiplying 85 with that 3.25%. Remember, you're always multiplying a percentage, so times 3.25 divided by 100. And that comes to £2.76. So £2.76. Now we want to do so that's the yellow, sorry. So that's the one I've done in yellow. Now we want to do the one in green, so the middle bracket. So first of all, we want to figure out what amount is being taxed here. And all we're doing is the 967 minus the 242. First of all, that comes to £725. And it's that we are multiplying by 13.25%. And that comes to £96.06. So the national insurance contribution, that is just these two added up. It's the £2.76 plus the £96.06. And we get £98.82. Okay, so Lynn pays 4.5% of her weekly wage into a pension. Her weekly income tax is £52.08. Calculate Lynn's weekly net pay. So net pay is where we're taking deductions away from the gross weekly wage. So remember, it's 1,052. So first of all, 4.5% of a weekly wage into a pension. So that's the weekly wage before the national insurance has been taken off. So you want to do the 1,052 times the 4.5%. That comes to £47.34. So that there is the pension. And now we want to find the net pay. So the net pay is the weekly salary, so weekly wage, minus these deductions. So we've got the national insurance at £98.82, the pension at £47.34, and the tax, which is £52.08. And that comes to a grand total of £853.76. So Jacqueline buys items online. So this is question 8, sorry. Jacqueline buys items online and sells them in her shop. Jacqueline bought a painting for £320 and sold it for £415. Calculate the percentage profit that she made. So the percentage profit, we want to find the profit first of all. So the original was £320, the selling price was £415, so we want to find the difference. So that's £95 profit. And now we want to convert that to a percentage profit. So to find the percentage profit, we take the profit, we divide it by the original price, which is £320, and then we times it by 100 to get it into a percentage. So we're doing 95 divided by 320 times 100. And we get 29.69% profit. So we'll continue with this for part B. So Eileen wants to buy a new dining table from the shop. It is advertised at a price of £800, but Eileen wishes to use a payment plan to buy the dining table. The total price of the payment plan is 14% more than the advertised price. And the payments are calculated as the deposit is a quarter of the total price, 10 equal monthly payments, followed by a final payment of £100. Calculate the total cost of each monthly instalment. So we've got 10 monthly instalments. We want to find the cost of the monthly instalments. So first of all, let's find the total price. So it's this £800 times, now it's 14% more, so 14% more. So that's going to be 114%, right? You just add that on to 100%. And then to get it as a multiplier, you're timesing it by 1.14. So the total price is 800 times 1.14. That's 14% then added on. And we get £912. So the deposit is a quarter of the price. So let's do the deposit. So it's a quarter. So let's figure out the deposit. So that is going to be a quarter of 912. So you do 912 divided by 4. So the deposit is £228. Then we got a final payment of £100. So we got a final payment of 100. There we go. So what we can do, because we want to find out what the monthly instalments are, so let's calculate what's left once you've taken the deposit and the payment of £100. So we've got 912 minus the 228 minus the 100. That comes to £584. So that's the amount that Eileen wants to pay over 10 monthly instalments. So monthly instalments, it's going to be this £584 divided by 10 months. So that comes to £58.40 per month. Okay, and this is the last question of the exam. So Jacqueline owns a shop in Edinburgh, New York, and Dubai. Jacqueline wants an item sent from her Dubai shop to her New York shop. It will be sent from her Dubai shop at 8:45 a.m. local time on the 24th of November. The expected delivery time is 90 hours. New York is 5 hours behind Edinburgh, and Dubai is 4 hours ahead of Edinburgh. Determine the local time and the date the item is expected to arrive at her New York shop. Now, there are different ways of doing this. What I'm going to do is show you what I think is the quickest way. But the beauty of maths is that there's lots of different ways you can do it. Well, what I'm thinking, first of all, is, well, if New York is 5 hours behind Edinburgh and Dubai is 4 hours ahead of Edinburgh, what's the time difference between New York and Dubai? Well, New York is going to be 9 hours behind Dubai. Another way to think about it, Dubai is 9 hours ahead of New York. Okay, so we've got 8:45 a.m. is when it gets sent. So 8:45 a.m. in Dubai time on the 24th of November. And it takes 90 hours. 90 hours. Wow. Okay. So let's figure out how many days and hours that is. So 90 divided by 24. That's going to be, so that'll give you 3.75 days. Well, what is 0.75 of a day? How many hours is that? So 0.75 times 24 is going to give you 18 hours. So it takes 3 days and 18 hours. So what we're going to do is add 3 days, 18 hours onto 24th November, 8:45. Now this is where I would subtract the 9 from here, because New York is 9 hours behind Dubai. So what you can do is you can add 3 days, 18 hours onto 8:45, 24th November, and then subtract the 9 hours after that. But what I would recommend is subtract the 9 hours from this time, because we're going to go over into another day. Adding 8:45 onto 8 hours, or 18 hours onto 8:45, sorry, is going to go over another day. So that'll be 26 hours. So what we can do, let's subtract the 9 hours from this. So let's go 3 days, 18 hours, minus 9 hours. To get it into New York time would be 3 days, 9 hours. And now it's a little bit easier to add 3 days, 9 hours to get into New York time. So New York time, let's add 3 days to the 24th of November first. Well, that's going to be the 27th of November. And the time, well, we're going to add 9 hours onto 8:45. So you do 8 plus 9 is 17. So 17:45. Just to give it into 12-hour clock time, so 27th of November at, so 17:45 is 5:45 p.m. New York time. And that is the answer. And that's the last question, so I hope that's been useful for you. Good luck in your exam.